time. Question number 3. On Saturday afternoon, Armand sent M text messages each hour for 5 hours. So he sent this number of texts. Again, this is a variable. We don't know how many texts he sent, so we're just going to call it M. If we knew how many he sent, we wouldn't use a variable. So we use variables in algebra to represent numbers that we don't know. So he sent M text, a certain number of text every hour for 5 hours. He does this for 5 hours. So the total number of text that he's going to send is going to be 5M. So if he sent like 10 texts every 5 hours, it's going to be like this: first hour, second hour, third hour, fourth hour, fifth hour. So the total number of texts that he's going to send would be 1 times 10. That's way too many texts, I think, but nevertheless, as an example. So he sent M number of texts for 5 hours, and then Tyrone sent P number of texts for 4 hours. So he sent P number of texts for 4 hours. That's the total number of texts that he sent were that many. So which of the following represents total number of messages sent by Armand and Tyrone on Saturday afternoon? Well, the total number is going to be this plus this, which is 5M plus 4P, which is over here. So he sent 5M plus 4P number of text total between the two of them. So that's not too bad. So that's question number 3. And let's do question number 4. That's about Kathy. Let's see what she's up to. So Kathy is a repair technician. She's doing something productive. It looks like Kathy's a repair technician for a phone company. So here's Kathy sitting there every day at a phone company repairing phones, probably because they're broken from busted from all that texting. Anyway, she says Kathy's a repairing technician for a phone company. So each week she receives a batch of phones that need to be repaired. The number of phones that she has left to fix at the end of each day can be estimated with the equation this. So she starts out with a certain number of phones delivered. So somebody brings in a whole bunch of phones, okay, and then she's got to fix them. That's her job. So the number of phones that are left at the end of the day is given by this equation, where P is the number of phones left, and D is the number of days she has worked that week. What is the meaning of 108 in this equation? I don't know. Okay, well, let's figure this out. See, questions like this are very, very common. See, somebody's doing some stuff, and then here comes an equation, right? So, and this particular thing relates to a very common problem, okay? I know the best example I like to give for this, or at least I can use commonly give, is, for example, if you have a helicopter. So here's a helicopter, okay? So here's a helicopter. It's at 5,000 feet. So it starts at 5,000 feet high, and it's coming down, that's right? Let's say it's coming down at like 200 feet per second. That's pretty fast, but it's coming down at 200 feet per second. See, now you can represent the height of the helicopter at any given time. So you can represent the height of the helicopter at any given time by saying, well, the helicopter starts out at 5,000 feet, and every second, you know, is going to come down by 200 feet for times t, where t is in seconds, and, in this case it's in seconds. It's pretty fast, right? It's falling or something like that. It's falling fast. So the height of the helicopter is represented by this. It's 5,000. That's the initial height, and it's being subtracted every second. It's going to move to minus 200. So after 2 seconds, it's going to be 5,000 minus 400. After 3 seconds, it's going to be 5,000 minus 600, like this. Now, this is a very, very common problem, because if you notice this, you have very similar things, something minus something over here, right? So what this is, and you have to understand what this is, like inside out, because this is like Algebra 1. It's like the heart of Algebra 1, really. So this is like the heart of Algebra 1. Why? Because this is y equals mx plus b, all right? This is like a linear function. Rather, what this is actually y equals b plus mx, right? That's what this is. This is the b, okay, minus, this is plus mx, where the m being is negative 23. So you have to recognize this as a linear equation, okay, as a linear function. This is a line. Y equals. See, if you don't understand, it's like this. If you live like, you know, if you live next to the Himalayas, and if you don't know what the Himalayas are, it's kind of like silly, right? Or if you live next to the Rocky Mountains, and if you look over here, look at the Rocky Mountains, you've been looking at it all your life, but you don't know what Rocky Mountains is, it's kind of plain silly, right? In the same way, if you go through algebra 1 and if you don't recognize y equals mx plus b, it's kind of like silly. So you have to be able to recognize y equals mx plus b pattern anywhere you see it. This is y equals mx plus b pattern, okay? So that's kind of important because in the y equals mx plus b, or in this case, it's like y equals b plus mx, okay? This is the y-intercept, and that's the slope. It's kind of like this, okay? Y equals b plus mx, right? So this is the y-intercept, and that's the slope. The slope is negative. M here is negative 23. M here is negative 200, all right? So that's the first thing I want to suggest about this question. You kind of have to recognize this as a linear function because that's kind of like the heart of algebra 1, right? Okay. And then if you knew that, then with 108, even if you didn't know that, 108 represents the total number of phones that she got delivered. So here's a stack of phones that she had given, like a whole bunch of stack of phones, okay, at the beginning of the week, okay. Now that's like 108 phones that she has to fix, and she's fixing. She can only fix like 23 phones in a day, so right. She can fix, it looks like she can fix only 23. So at the end of the first day, she's going to have minus 23. At the end of the second day, she's going to have another 23 done. At the end of the third day, she's going to have another 23 done, like this. Okay? So what does 108 represent in this case? It represents the number of phones that she started out with. Okay? So that's, you can answer that question without knowing the nuances and the beauty of this question, that this is a question about a linear function, right? So Kathy will complete repairs in 108 days. No way, it's too slow. Kathy starts each week with 108 phones to fix. That's what it is, okay? So Kathy starts with 108 phones to begin with, okay? Now let me tell you something else about this. Okay, now if you were to graph this thing, okay, so this would be like 108 right here would be like the y-intercept, and the slope would be negative like this, or something like that. You follow what I'm saying? So the line would look something like this. There will come a time after a certain number of days you won't have any phones to do. So this is a line. So if you can rewrite this, if you want to please, like this, 108. Okay, this is y-intercept, and that's the slope. Okay, so this is a classic y equals mx plus b slope-intercept form of a linear function. You gotta be able to recognize them linear functions. Okay, right.